Understanding Radians, a tutorial by Nicolette, Jeantilus. Vocabulary for this tutorial. Circle. A closed two-dimensional figure in which the set of all the points in the plane is equidistant from a given point called center. Source, bijus. Similar. A quality describing figures having the same shape, having corresponding sides proportional and corresponding angles equal, and being able to be transformed into one another via proportional dilation, rotation, reflection, and translation. Sources include dictionary.com and Math is Fun. Circumference, the measure of the outside boundary of the circle, the length of the circle, or the perimeter of the circle. Source, Attribution. Radius, plural, radii, the distance from the center of the circle to the outer line. Source, bijus. Diameter, the line which divides the circle into two equal parts, is also equal to twice of the radius, and passes through the center. Sources include Attribution and bijus. Arc, a portion of the circumference of a circle. Source, Math Open Reference. Angle, the figure formed by two rays, called the sides of the angle, sharing a common endpoint, called the vertex of the angle. Source, Q Math. The small diagram in the square depicts a central angle. Unit circle, a circle with a radius of 1. Source, Math is Fun. First, let's confirm a few rules, or truths. This will help us understand the reasoning behind radians. 1. All circles are similar. That is, they are of the same shape and can be transformed into one another through proportional dilation, rotation, reflection, and translation. 2. Every two radii in a circle form an angle. This is called a central angle. 3. Every arc length can be associated with the angle created by two radii, or the central angle. 4. Radians are a measure of arc length, and henceforth can also be associated with an angle. Second, let's discuss pi. The formula for pi is pi equals c divided by d, or pi equals circumference divided by diameter. In a unit circle, pi will always equal circumference divided by 2. This is because one diameter length is equal to two radii lengths, or d equals 2r, and every radius in a unit circle is 1 unit. Since pi equals c divided by 2, we can solve for c by multiplying both sides of the equation by 2, giving us 2 multiplied by pi equals circumference divided by 2 multiplied by 2. This simplifies to 2 pi equals circumference. As I mentioned earlier, every arc length can be associated with an angle. Circumference is associated with 360 degrees. Henceforth, 2 pi is equivalent to c, and they are equivalent to 360 degrees. 2 pi is the radian measure of 360 degrees. Likewise, pi radians equals 180 degrees. Now, let's find the value of 1 radian, which is equal to 1 unit of arc length. We will use the equation of pi radians equals 180 degrees. First, add the invisible denominator of 1. Pi over 1 radians equals 180 over 1 degrees. Next, retrieve the 1 radian by multiplying both sides by the reciprocal of pi divided by 1. or 1 divided by pi. The resulting equation is pi over 1 multiplied by 1 over pi equals 180 over 1 multiplied by 1 over pi. This simplifies to 1 pi divided by 1 pi equals 180 divided by 1 pi. Once simplified, this gives us the conversion ratio pi over pi equals 180 over pi, or pi radians divided by pi radians equals 180 degrees divided by pi radians. Simplified once again, we find 1 radian equals 180 over pi. So 1c, c standing for circular measure or radians, is equal to 180 divided by pi, or 180 degrees divided by pi radians. We can use the reciprocal of 180 degrees divided by pi radians as a conversion factor. That is, 180 degrees over pi radians equals 1, which equals pi radians over 180 degrees, which also equals 2 pi radians over 360 degrees, which equals 360 degrees over 2 pi radians. Next, we are going to use those ratios to convert angles into radians. We'll start with the most commonly used angles: 30 degrees, 45 degrees, 60 degrees, and 90 degrees. 30 degrees multiplied by pi radians divided by 180 degrees equals 30 degrees multiplied by pi radians over 180 degrees. The degree units cancel out here. This equals 1 pi radians divided by 6, or 1 pi over 6 radians. Likewise, 45 degrees becomes 1 pi over 4 radians. 60 degrees becomes 1 pi over 3 radians. And 90 degrees becomes 1 pi over 2 radians. We can also view these angles in radians as parts or fractions of a circle. 30 degrees is 1/12 of 360 degrees, and 1/6 of 180 degrees. This can be rewritten as an equation. Is can be replaced by equal or the equal sign, and of can be replaced by the multiplication dot or the multiplication symbol. That is, 30 degrees equals 1 over 12 multiplied by 360. We also know that 360 is equal to 2 pi, and henceforth we can interchange them in this equation. This is also to say that the arc length of 30 degrees is 1/12 of the circumference, 2 pi. 30 degrees equals 1/12, or 1 divided by 12, multiplied by 2 pi. This simplifies to 30 degrees equals 2 pi over 12, which then simplifies to 1 pi over 6. Now, we are going to convert some more obscure angles. 120 degrees multiplied by pi radians over 180 degrees equals 120 degrees multiplied by pi radians divided by 180 degrees. This becomes 2 pi over 3 radians. We repeat this process for angles 220 degrees, 330 degrees, 135 degrees, 315 degrees, and 335 degrees. 220 degrees becomes 11 pi over 9 radians. 330 degrees becomes 11 pi over 6 radians. 135 becomes 3 pi over 4 radians. 315 degrees becomes 7 pi over 4 radians. And 335 becomes 67 pi over 36 radians. Finally, we return to the first truth that we confirmed. All circles are similar. This truth ensures that, regardless of radius or diameter length, an angle created in different circles will always be the same fraction of that circle and can be associated with the same radian measure. 30 degrees will always be 1/12 of 360 degrees and 1/6 of 180 degrees. And 30 degrees will always create an arc length that is 1/12 of the circumference. The following 2 slides include my references. Links to these sites will be in the description box if you would like to review them for yourself. Thanks for watching! I hope this helped explain radians. If you have any questions or if you feel I have missed something, please feel free to leave your thoughts in the comment section.